from? Okay, I think we are good to go. Right, so my name is Simon. I'm a master technician for Jaguar Land Rover, and I also help out on the Ford team. Today, as you can see, we are going to be covering some of the communications networks that you're going to see on Jaguar Land Rover vehicles. Now, bearing in mind, a lot of this stuff is fairly generic across all manufacturers, so you should be able to apply some of this knowledge to, other vehicles you're going to be working on. Because this course is there's a lot to cover in this course. What I've tried to do is capture some of the most important stuff that I get asked, or some of the more regular questions I get asked on a day-to-day basis regarding CAN communications networks. So without further ado, let's just carry on. As it says, if you've got a question, pop it in the chat. Okay, I will then try and answer as many questions as I possibly can in that time. If I haven't, I will always try and endeavour to send me an email. I'll try and get a hold of you that way. So today, what we're going to be covering is just a very brief introduction to CANbus systems. So like some of the early iBus, KBus, PBus, that sort of stuff, and then moving on to the newer CAN. Okay. I'm hoping that if there is enough interest on a further webinar, I will then go into FLEXRAY and some of the other stuff on there. Okay. So to start off with, multiplexing. So in the very beginning of CANbus time, we had the lovely P38 Range Rover, as some of you've probably seen. Now, because of their systems were quite basic, they didn't have multitudes of ECUs like we have on like the Disco 5s and stuff like that. They just had what's called serial communications networks. So dedicated signal lines linking ECUs to each other. So in this case, you can see you got the engine ECU, it was transmitting the engine speed, the torque, pedal positions, gear module was then sending the gear positions back up again. And so you just ended up with multitudes of wires just going everywhere. Okay, it was very impractical. You had lots of redundant sensors, and it just wasn't needed anymore as the car started to improve and get more complex. So that's why we have CANbus networks, which is what you see on that image at the bottom there. So you have literally two wires that link ECUs together doing the same job. Okay, it's a lot more efficient. It allows bi-directional data transfers and sensor sharing rather than having all of this messy wires going everywhere. Again, and this is what you can see from this diagram here. Everything is much clearer. You've got reduced wiring harness sizes. You've got greater system reliability. No more redundant sensors, reduced costs, and also it allows more flexible configurations. Okay. Now, going on to the next slide, you will start to see that there are three main structures of CANbus networks that you're going to have. Okay. The most common one you're going to see is a linear network, which is that top diagram there, otherwise known as a tree. Other ones that you will see are ring and also star. So the ring structure you'll probably recognize straight away because that's one off of a fiber optic systems bus. Okay, and star, well, that's the very latest in CAN technology. So that is FLEXRAY. Okay, now I will go over the benefits of each one. Is hopefully in a later video, but essentially I'm just going to be sticking with the linear or the tree network here, okay, as it's the most common and it's the one we see most of the time at the moment. Okay, now on the next screen, as you can see here, all right, the best way I could possibly describe CANbus networks is, or multiplexing, is using Morse code. Okay, so multiplexing relies on digital signals between control units. All right. Now these digital signals consist of a series of high and low voltage signals. High and low voltages signals which represent bits of information. Okay. And it is very similar, as I said, to Morse code or telecommunications network. Okay. So it goes back to this zeros and one business that you're probably used to seeing on a day-to-day basis. Okay. One pulse, so one little square wave, is one bit of information. Okay. And it takes 8 bits to form 1 byte. Now that's, again, you're probably used to sort of seeing, like on internet speeds, you know, you've got 8 megabits and everything else like that. Now, early Land Rovers and Range Rovers used iBus, KBus, and DBus. Okay, now they worked at 9.6 kilobytes per second, so that's 9,600 bytes of information per second. Okay. And the way it works is that the zeros basically means not set, and 1 means that it is set. Okay. In terms of voltages on iBus and KBus, it's typically around about 3.5 volts is a set signal, 0 volts is not set. So you get these 2 switching states. Okay. As there are only 2 possible states for a bit, okay, which information a bit combo carries in the data frame is called the protocol. Okay, and that's used in the software development stage. Again, so this is the sort of stuff that you will see on a square wave information. All right, so you've got dominant and recessive signals. The dominant signal is logical 0, which is here on the diagram in 6. The recessive state is 1. So it says on off data, and it's very, very quick. It's very, very rapid. Okay. Now, if we just go to a diagram next here, you can see what a single wire communication network is. So your likes of iBus, PBus, KBus, DBus, they are all single wire communication lines. So you have one dedicated master module, okay, with all of these subscriber ECUs then connected to it in series. On this, which is off of a L322 Range Rover, everything goes through the instrument panel. Okay. Now, iBus, KBus, DBus, you're probably already thinking, like, what am I on about? Okay, so technically speaking, they are all identical. They are all single wire communication buses, but the way that they are used is slightly different. So the iBus is mainly used for infotainment. The KBus is going to be for your driver aids and comfort systems, okay? And the DBus is what's going to be connecting your auto logic to the rest of the vehicle, okay? It's very slow data compared to modern day CAN. As I said, 9,600 bytes per second. It had its beauty. It was very simple, okay? But the big downfall is that if you can imagine, as you're looking at this wiring diagram, let's say this header connection got full of water, all right? You're going to lose comms to every single one of these, and possibly the likes of these as well, okay? And this is where CANbus then starts to come in, okay? Guys, take a screenshot of this, because this is what iBus, KBus, DBus scope pattern will look like, okay? So this is what you're looking for when you're doing your diagnostic works, okay? Now, I get it, some of you don't have an oscilloscope, all right? But the beauty with iBus, KBus, DBus is that the voltages are quite fairly stable, and you can pick them up fairly easily with a multimeter. Okay. What you may see with a multimeter, if you were to probe in on one of these points, if I just go back briefly to this diagram, so let's say you were, I don't know, testing it at the heating and ventilation panel, you would probably just see a stationary 12-volt signal. Depending on how good your meter is. I mean, some fluke meters, you might see a voltage fluctuation between 5 to 7 volts. What does that mean for us? Well, basically, we can use that to do our diagnostics work with. So if you were to see a constant flat line 12 volts, okay, this could be an indication that you've got no communications taking place at all. All right, it could be that the bus is offline, or you've got a short circuit to 12 volts. Okay. You may also see a flat line at 5 volts. Okay, that would be an indication that you've got no output voltage from the master ECU, such as the instrument pack. It could be that one or more of the bus lines is open. It could also be a control unit defective. Okay, now going back to this diagram, the beauty with iBus, CANbus, and DBus is that you can quickly identify which of these ECUs, if it is an ECU fault that is causing the problem, to just start disconnecting them one at a time. Okay, quite a lot of the time, specifically on L322s, okay, we do have problems with the steering column locks. We also have problems with the headlamp leveling ECUs. Okay, so finding those ECUs and start disconnecting the common culprits, or just start disconnecting them one at a time. What you might then find is if you disconnect the body control module, you might suddenly get comms back to your instrument cluster, the steering column lock, in which case you just have to go straight to the body control module, checking your powers and grounds to that ECU. So that is the beauty with these types of systems. They have their flaws. If one goes down, the whole lot goes down, but it does make diagnosing a bit easier compared to CAN. All right. As I said, the typical sorts of stuff that you will see is short circuit to positive, short circuit to ground, open circuit. Header connections on that previous diagram are quite common for getting water ingress into them. And it is literally a case of the fastest method is disconnecting them one at a time to see if you can get communications back to the rest of the ECUs. In terms of short circuit, well, again, what you're going to have to do is get a wiring diagram, phone us up, or if you've got an access to the wiring diagram, just start checking what your CANbus voltages are to each ECU within line. Okay. A useful test and a good way to test the iBus and the CANbus on a Land Rover, just before I go on to the next screen, is for the CANbus, is hold the ignition key just above the ignition barrel. So like on the likes of early L322, so 2005, 2006 era, you have the ignition barrel down in the center console near the gear selector. If you hold the key just above the ignition barrel, quite often you can hear the solenoid pulse. Okay, you will hear that solenoid click in and out is an indication that the CANbus is working. Okay. iBus, if you want to test that the iBus is working, if you put the hazards on, do the telltales come up? You know, the little hazard lights inside the instrument cluster, do they start to flash at the same time? Okay. Similarly, if you operate the volume control buttons on the steering wheel and the radio unit works, then you can tell that most of the iBus system is working. So if you're ever in doubt, you know, has the whole CANbus or iBus system gone down? Those are two quick and easy checks just to see if the whole network's gone down, or is it just possibly, you know, one ECU that's dragging it down. Okay. Moving on to CANbus. Okay, so CANbus networks. There are two networks which you're mainly going to be dealing with. Okay, high speed and medium speed. Okay. And there is a gateway module that links the two networks together. All right, as this lovely diagram here shows, medium speed is at 125,000 bytes per second. High speed is at 500 kilobytes per second. Okay, gateway modules are needed to share messages across from medium speed CANbus networks to high speed CANbus networks. So, for instance, I'm trying to think what you might need to know. So, Door modules, you might need to know road speed information from ABS, and so in order to transmit across from the medium speed to the high speed network, it has to go through a gateway module. Okay. Now, in this diagram, I've chosen a Range Rover Evoque, and you can see from this diagram that the gateway module is inside the body control module. Okay. Land Rovers tend to use the body control module or the instrument cluster as their gateway unit as a rule of thumb. Okay. It's only recently, and I'm talking from about 15 model onwards, 17 model onwards, that you get a dedicated gateway module. Okay, those ECUs are working exactly the same way. It's just for convenience and better efficiency, and like everything, cost is the reason why they've gone for a dedicated gateway module over, you know, sort of like a Disco 3 where they've integrated it into the instrument cluster. What was I thinking? Right, so high-speed CAN. So high-speed CAN is generally going to be used for powertrain and chassis systems. Okay, medium-speed CAN is going to be for your body and comfort systems. Okay, CANbus differs from iBus and KBus is that it is a two-wire system rather than single-wire communication. So you have two copper wires twisted together, or on some of the really, really early ones, all right, you used to have three wires, where the third connection was added just to serve as a shield against interference, okay? Now, you get interference on CANbus lines because of the relatively low voltages they use. So CAN typically works on around about 2.5 volts, okay? That's a generic across most manufacturers. Some, like when I used to work for BMW, they work on 4.6. It's irrelevant, but generally CANbus is a 5-volt system, so 2.5 volts on each wire, give or take. All right, but it's very vulnerable to signal interruptions from higher voltage circuits. So cell phones, dash cameras, you know, ignition systems, all that sort of stuff. So you needed some way of protecting the CANbus network from this interference. So on early vehicles, you used to have this shield wrapped around the cables. But now what you will see is they twist the wires together, and they've also added what's called terminating resistors inside the networks. Okay. And that is just to eliminate interference and to stabilize the CANbus signals between ECUs. All right. As I said earlier, this course is trying to cover as much information as I possibly can in a really short frame of time. So if you've got questions, I'll try and answer them a bit later on. So in this diagram, you can see you've got terminating resistors here in the powertrain control module. You've also got them in the body control modules, and also in the instrument pack. Okay. Another telltale giveaway when you see a gateway module is you will have several, when I say several, 2 or more terminating resistors in an ECU. Okay, that's usually a telltale sign of which is the gateway module. So right, lost my train of thought. Moving on. So here in this diagram, okay, I've tried to give you a bit of an idea of how a gateway system works. Okay, so it's a very simplified diagram. So this is off a 2010 Freelander 2. So what happens is in this one, you've got the engine temperature display is faulty on the vehicle. Okay. So the fault memory indicates the network communications fault. So the engine temperature is calculated by the powertrain control module from the input signal of the engine coolant temperature sensor. The signal then obviously goes through an analog to digital converter within the PCM. The PCM then puts this onto the CAN network. All right. And you can see I've put a couple of terminating resistors just to sort of show it. Here you've got the gateway module. All right. The signals is then transferred between the high speeds to the medium speed CAN network, onto the medium speed CAN, and then onto the instrument cluster. Instrument cluster then converts it into a display that we recognize, and it turns the signal, into an analog one to move the dial. Okay. So that is what a gateway is. Very simplified. It's nothing to be too scared about. All right. It's a useful tool. So if you ever come across a car which has got comms to absolutely nothing, okay, so usual ones are Discovery 3s are particularly good for those of you who worked on it. If you've ever seen a car, Discovery 3, come in and the hazard lights are flashing, the dashboard's lit up like a Christmas tree, it's non-start, the door locks might be going on, off, that's usually a telltale sign that the whole CANbus network has gone down, okay? And when you first plug in your autologic scanner, you do a quick test. If you see that there are multitudes of CANbus errors or nothing's communicating at all, then that's usually a telltale sign that the gateway module's gone down. If you can't talk to anything, like on the high speed or the medium speed, have to look at the gateway. What's possibly taking out the gateway module, okay? Now, on a Disco 3, it's usually the instrument cluster because they're made of cheese, but that's neither here or there. But it is a good place to start most of your diagnosing if you do come across a car which is communicating to nothing. Okay, go straight to the gateway module. This diagram, so again, just a simplified explanation of what the terminating resistors do. So these terminating resistors, as I said, are for interference purposes and to clear up the CANbus signals. Okay, they are 120 ohms each. Okay, so you'll have one, as I go back to that slide as I showed earlier, you've got one in the powertrain control module and you've got one in the body control module. What does this mean for diagnosis? Well, it's actually quite handy because if you were to plug in your autologic, your multimeter at the OBD socket, okay, and you were to do a resistance check across the terminals, what you will see is 60 ohms, okay? Now, you've got to be careful when you're doing your resistance checks on these, because what you'll see is if you don't disconnect the battery, you might get some very strange readings, all right? Potentially cause some damage as well. So disconnect your battery and you're going to measure the resistance across the OBD terminals. I've got a slide set up in a few slides down the line where I can show you which pins to go onto. But because it's a parallel network, and for those of you who remember your high school or secondary school voltage, the little diagram of V equals, V and IR, all right? You have 60 ohms at the OBD socket on a good car, all right? If you're seeing 120 ohms, the circuit has gone open circuit, all right? 0 ohms is the CANbus is shorting together, or you've got a short to ground somewhere. So 60 ohms is what you're looking for if everything's working at the OBD socket. 120 ohms is open circuit, okay? You'll see that in a few slides because I have prepared a few more things, okay? So let's move on a bit more because I'll be coming back to the diagnosing of CAN in just a second. So CAN protocol. So part of each control unit on a CANbus network contains a transceiver. So as the name suggests, it can transmit and receive data in binary form. So data that is present on the CAN is received by the transceiver and does so by measuring the potential difference between the CAN high and the CAN low. All right. So going back to that zeros and ones and logic. So logic 1 is typically above 2.5 volts, 2 volts, sorry, and logic 0 is typically below 800 millivolts. Okay. So This one, I've just simplified the high-speed CAN on a Discovery 3, okay? And as you can see, they are essentially a mirror image of each other, okay? Logic 1 and logic 0, if you want to call it that, can also be determined as recessive and dominant signals, okay? So on the CAN high, your recessive is 2.5, your dominant is 3.5. On your low, your recessive is 2.5, your dominant is 1.5, okay? What this means is that when it comes to your diagnosis, if you haven't got an oscilloscope, all right, you will only ever see the recessive signals, all right, which is why when it comes to diagnosis, as much as we like to bang on it, a scope is the best one, okay? But multimeters do work, but the thing is with multimeters, you just can't see the dominant signals, so the switching and the signals taking place, all right? Here is a really good scope image of a high-speed CANbus network, okay? So you can see the CAN high here in blue, all right, and the CAN low here in red, all right? It is a mirror image of each other, okay? Don't worry about some of these little spikes. You will see them on pretty much every single CANbus diagram, unless you've got some of the filters in place, some of the attenuators, but that's for another video. I'm not going to go into that just yet, but this is a good network. It's a mirror of each other. You know, you can see the CAN high is nice and clean, the CAN low is nice and clean, there's no interference. If there was interference, what you would see is, you know, either a flat line, you would see a squiggly wave, like a sinusoidal waveform, okay? Flat lines tend to be indication of a short circuit, okay? So 5 volt flat line, you've got a short circuit to 5 volts, 0 volts, you're short to ground, okay? Now, as I said, we've got a lot to cover in, and I've only got a few more minutes left before we have to start going into some questions. So on Disco 3s and Disco 4s of the likes, you only had 2 CANbus networks, okay? A high-speed CAN and a medium-speed CAN. As cars have become more and more complicated now, so Evokes, Disco Sports, Velars, and everything else like that, you have a lot more systems going on. You've got rear climate, you've got rear entertainment, you've got in-control touch, which is the new infotainment system. It's just a lot of stuff to handle, and traditional CANbus just doesn't work anymore. Okay, so they've had to introduce what's called quad-amp. Now, it's not as scary as what most people tend to think it out. It is exactly the same as traditional CAN. Okay, so you've got 2 high-speed CAN networks, 2 medium-speed CANbus networks. All right, the medium speed still handles the comfort and infotainment systems. The high speed still handles the powertrain and the chassis. Okay, but what it's split up to now, okay, is high-speed powertrain, high-speed chassis, high-speed body, and high-speed comfort. Okay. Now, just to go back to what I was telling you about resistance checks, this is, you know, got an OBD picture here. So what you would do when you get your vehicle in for a diagnostics, the first thing you want to do is do a network integrity test of the vehicle. So scan the entire car. You can do that with the Drive Pro, Sys Plus, or if you've got it, STD Pathfinder can also do it. What it does is it reads the entire car, all right, and it will display what ECUs are communicating and not communicating. Okay. Now, if you're finding that luckily it's only one network that's gone down rather than the whole lot, it narrows down your search quite considerably, because you would only need to check, you know, let's say the high-speed powertrain rather than having to test every single one of them for resistance and voltage checks. Now, as I said, I've put us in here some slides of what good reading is and what bad reading is. Okay, so 60 ohms is what we're looking for, not 120, not 0, because those are bad. Okay, and again, just to reiterate, disconnect the battery when you're doing your resistance checks. Powertrain chassis. So this, as I said, they all work on the same voltages. So CAN high, if you're doing your multimeter checks on the powertrain chassis, you're looking for 2.7 volts on the high and 2.3 volts on the low. Okay, now that is going to be the same on every single CANbus network. So whether it's medium speed, high and low, powertrain high and low, they all work on 2.7 volts on the high side, 2.3 volts on the low side. And when you're doing resistance checks, it's always 60 ohms. Okay. Now these next few slides, I'm just going to show you some scope images of what a quad CAN image looks like. Okay. So here you've got your high-speed CAN powertrain. So between 2.5 and 3.5 volts on the high. Low side between 2.5 and 1.5 volts. Chassis CAN, again, the waveform near enough identical. Voltage is very similar, you can see. So it's nice and easy. It's not like a BMW where you've got voltages, starting at 4 volts, and it's nice and simple. Land Rover, they keep it very uniform across each network. So that's your chassis CAN. Here you've got your Bodycam. Okay, again, 3.5, 2.5, 2.5, 1.5. So nice, clean, square wave images of each other. These were taken off a 2016 Range Rover Sports. Okay, and that is your comfort CAN. Again, if you've got some questions in the chat or you want me to go back over the slides, just let me know. I'll let you take pictures or whatever you need to do. So, in terms of diagnosis, well, the first thing you want to do on a fault-free CAN network is, as I said, you're going to go to the OBD network and you're going to do your resistance check with the battery disconnected. You're going to go across the 2 pins for the CAN that you're investigating. So, for instance, this is a medium-speed CAN network. We've gone into it and we've got 60 ohms. So that means that the terminating resistors and the overall resistance in the circuit is okay. All right. Next, you will then need to check the voltages on those CANbus networks. All right. So you're going to connect the battery back up, all right, because you need the battery connected when you're doing the voltage checks. And you're going to do red probe into, if for instance, if it's on the high-speed CAN powertrain, it's pin 6, and you're going to put your red probe on a good earth. Now, I tend to use either pin 4 or pin 5 of the OBD socket because that's your earth on the OBD. All right, but whatever earth you can find, as I said, if I just go back a couple of slides, you will see what I mean. Come on, yeah, so 4 and 5. Okay, those are your ground points. That's your terminals. That's your terminal 30, so pin 16. So that'll have battery voltage on it all the time. So if you want to test your meter at the same time or zero it, whatever you need to do, then you can all do it at the OBD possible. Is it possible to copy the slide pages used in the webinar? I'm sure it is. If not, I can speak to Nicola at the end to see if we can get that. But yeah, Wayne, I'll answer your question in just a second. I'll get these slides to you somehow or another. Okay. Anyway, so voltage checks. So CAN high 2.7 volts as a rule of thumb, and CAN low will be 2.3. Okay, so that's just average voltage checks. These are quick and easy checks that you can do just to test the overall integrity of the CAN, all right? But again, you're only measuring the recessive signals. You're not picking up the dominant ones. So it's all very well as a quick check, but you won't actually be able to tell whether there's any data transmissions between the ECU, okay? What you may find is that you'll have an open circuit on the CAN network, all right? And if it is open circuit, easiest way will be when you do your resistance checks, because you'll have 120 ohms. Okay. Similarly, if you've got your short circuit, all right, or the CAN bus is shorting together, then you will have 0 ohms on the CAN. Okay, it's just nice and easy. And what you can do is, this is where it then becomes a little bit tricky. And this is where a lot of people ask me questions. Well, okay, we've identified that there's a short circuit, we've identified there's an open circuit, whatever. What do we do? Well, the next thing that you probably want to start doing is, and the method that I do, is what's called the half split technique. Okay, so you would load up your wiring diagram, okay, to find a connector which is halfway through the middle of the car. All right, you would then disconnect that connector, and what you could do is you could do the same test that you've just done with your multimeter at both the male and the female side of the connector. Okay, because what you're kind of hoping for is that if you've split the car in half and one half of the car comes back to life, okay, and the other half of the car is dead, you've narrowed down a lot of legwork to try and trace where that ECU is. So if you've disconnected, I don't know, the connector, it's in the right hand bottom A pillar, all right, and you've gone onto the male side, you've done the same voltage checks, you know, you've got 2.7 on the high, 2.3 on the low, you've then done the resistance check, you've got 120 ohms, and remember, because you've split it in half, you have caused an open circuit. So if you get 120 ohms and the 2.7 and the 2.3 volts, right, that means that that half of the car is okay, you know, that hasn't got the fault. You might go to the other side of the connector and you might find out I've got 0 volts or 5 volts on one line and 0 resistance. Okay, that might give you an idea, right? Okay, well, the fault is on that half of the car rather than the other half. So then you start following your way down through the wiring diagrams, going to each ECU in turn, checking the CANbus voltages at each ECU, checking your powers and grounds to those ECUs. Or alternatively, what you can do, and I know some people do it, they just start unplugging the ECUs one at a time to see if you get communications back to the vehicle. Okay, it's entirely preference. I find that the wiring checks are a little bit more accurate, especially on Land Rovers, where some of these ECUs are buried. Some of them are like tucked up behind the glove box and a real nightmare to get to. Some are down in the center console. Some have to take the seats out to get to them. It's a bit of a nightmare, but ultimately the half split technique seems to work, in my opinion, the best way of identifying where the fault lies, because you're only checking half of the car rather than the whole car, wasting a lot of time. Okay. Again, it's quite specialist equipment. Some people don't have them, but breakout boxes really do help as well when it comes to diagnostics checks. Okay, because you can plug them in line at the OBD socket. So whilst you're scoping, you can also be doing some voltage and wiring checks at the ECU. Okay. Again, I've just put a couple of notes here on the slide because it just shows that when you do a network integrity test, several modules of the bus are malfunctioning, you've got to test everything. Whereas if it's just one ECU, that's not communicating. So you might find that, I had one the other day, for instance, it was a Range Rover, and it was lots of warning lights on the dash. It read the fault memory, and there was only a couple of ECUs reporting communication faults, but we looked at the bit further, and the instrument cluster had basically said, I've lost comms with everything. I can't talk to the engine, I can't talk to the gearbox, I can't talk to the parking brake, I can't talk to the parking assist. But you go into those ECUs and there was no mention of can't talk to the instrument cluster. Okay, that's usually a telltale sign that it's the cluster rather than anything else on the car which is causing you your issue. Because CANbus, and as one of my colleagues often says, it's often the case of the noisy neighbor. So the noisy neighbor is what will corrupt the CANbus. Okay, so if you see that, like in that instance, the instrument cluster is complaining about communication faults with everything, but nothing else is talking about communication faults with the cluster. It's the one with all the communication faults, generally, as a rule of thumb, which is causing you your issues. So you would go to that ECU, check your powers, grounds, and CAN voltages to that ECU. If they're all okay, all right, and you do a quick voltage resistance check at the OBD socket, and it's all okay, then you know you've got a module fault. Replace the ECU, all right? Luckily, in terms of CANbus test, if you just want to check comms, okay, again, take this with a pinch of salt. For testing comms, fitting a donor ECU off another car is fine. As a permanent solution, no. Okay, so if you just want to test out communications, let's say you found a fault with the body control module, get a body control module off another vehicle, plug it in, all right, obviously the same make of vehicle as the one you've got, plug it in, you should be able to communicate to it. And you won't be able to start, all right, and you probably have lots of warning lights still on the dash. But if you can communicate to the ECU and you get thin mismatch fault codes and multitude of other invalid data faults, but you can talk to it, then you know you've confirmed your issue. It's definitely the module rather than the wiring. That's something else you can do. I haven't got a problem with it. I'm sure the guys here as well haven't got a problem with it for testing out ECUs. For testing comms, swapping out ECUs is fine. Okay. Again, take it with a pinch of salt. Like everything, there is a bit of a grey area. On the old L322s, I'm talking 2003 to about 2006 Range Rovers, body control modules and light check modules. Be careful when you're swapping out those types of ECUs into the vehicles, because they contain a VIN number, but they also contain a mileage. Now, the VIN number is not a problem. The mileage is, because when you fit those ECUs for testing, it can, I'm not saying it will, but there is rumors, and it's happened to me a few times, that it will take the mileage off of the vehicle. Okay, so it will always take the higher mileage off the ECU that you swapped out. As far as I'm aware, it's only the light check module and the body control module, and it only seems to affect the L322, so the old Range Rovers up to about 2006. So, like everything, guys, yes, if you want to do it, swap it out for testing purposes is fine, but just do some research, maybe give us a bit of a call beforehand just to confirm if it is safe to do so. But as a rule of thumb, swapping it out just for testing, not a problem. Haven't got a problem with it. Right, guys, I've sort of gone on for about 40 minutes now. The aim of this course was really just to try and give you a bit more confidence when it comes to approaching CANbus faults. You know, a lot of people, they plug in their Autologics, they get these cars in, you know, it's coming on a recovery truck, there's warning lights everywhere. They plug it in, do a quick test, and they say, unable to talk to this, invalid data received from this, lost comms with all of this. And they just panic. It's like rabbits in the headlights. So I wanted to put this together to try and give you all a bit more confidence when you're tackling CANbus faults, okay? Whether it's just plugging in a scope and just, you know, testing the CAN network, or just using your multimeter, having that bit of information. And if you get stuck and you've got that information, just drop us a case saying you've got this far. That helps us out massively, because then we don't have to start all over from the beginning. But I just wanted this to be, you know, a good, broad spectrum, basic CANbus webinar. So it gives you the confidence to do some basic checks on your own, okay? But I do strongly recommend those garages that are going to be taking on those. If you want to get into it, please try and get an oscilloscope, because it does make your life and our lives a lot easier. But at least have a multimeter and wiring diagrams, or ask us for some wiring information. We'd go through it together. But don't be scared of CANbus. It's not this big, scary, oh my God, you know, what's going to happen? When you start looking into it, it's a lot easier than it looks, than it makes it out to be. Okay, I'm going to open up the chat now for anyone who's got questions. So yeah, let's start. Yeah, so as Nicola just stated on there, the webinar is going to be available later. Alternatively, I will speak to Nicola about maybe putting an email address or something like that, where I could put some of these scope patterns on there for you and get them out that way. Don't know whether that's something we could do, Nicola. I know Nicola's listening, so she'll hopefully get to us. Indeed, yeah, we can send a PDF. So there we go. So if you guys want a email with this, I can always put it together. We can get it to you guys. Yeah. So not many questions. So I'm hoping that's answered a lot of people. Oh, here we go. Do you know if the software for my 2016 model will be released soon? That doesn't really apply for this webinar, but I do get your frustrations. 2016 model vehicles are being developed, so yeah. You're asking the wrong question to the wrong chap, unfortunately. Could you explain the way module again and send the PDF? Sorry, Adam, what do you mean by explain the way module again? As in how the, oh, right, the gateway module works. Right, okay, yeah, sure. Let me go back to the slides for the gateway module. If I can get there. Slowly but surely. Okay, so the gateway module is the link between the two CAN networks. Okay, so the medium speed and the high speed CANbus, or in this instance on this slide, between the 4 CAN networks. A gateway module is essentially just an ECU that transfers the data between high and medium speed. So what it will do is it will get the signal in from, let's say, the engine ECU, and it wants to go to the instrument pack. That data needs to be slowed down so that it can be then put onto the medium speed, because as that lovely image of the train showed, if I can go back to it. There we go. You've got the high speed, which is working at 500 kilobytes per second, and the medium speed, which is working at 125. The messages need to be slowed down in order to be put on the medium speed CAN network so that it's shared. The gateway module is just like a normal ECU. On Disco 3s, it was the instrument pack. On some of the newer Evokes and Range Rover Sports, it's a dedicated ECU, and all it is, as the name implies, it's just the gateway between the 2 or 4 CANbus networks. It just transfers data. On the newer vehicles, the gateway module also does a lot of the stop-start information. It also helps monitor the battery and charging. And we do have quite a few issues with those gateway modules. But I hope that's kind of answered your questions. As I said, if the gateway module goes down, all right, so let's say there's an internal short with the gateway module, or sometimes what can happen, Disco 3 is another really good one. If the medium speed CANbus network goes down, all right, quite a good one was the heating and ventilation panels used to fail, all right. And then that would short out the medium speed CAN network and drag the gateway down with it. And so then the car would be non-start, the hazards start flashing, the door locks go on and off. So that's an indication that the gateway module's gone down. Similarly, if you do your network integrity test and you've done a quick quick test, and nothing's talking at all on the CAN. So you might have on the autologic, you might see a report. It will say 0 modules with faults, 40 ECUs not fitted or not responding, and you'll scroll down through the bottom of the list, and you'll have all of these ECUs just go, can't talk to this, can't talk to the body, can't talk to the gearbox. That's usually an indication that the gateway module's been taken out. Now, it could be a fault internally with the gateway, it could be a short, which is where you then need to do this, start off by doing your voltage and resistance checks on the OBD socket. That will indicate whether you have got a short. If your voltages and resistances are okay, then it'll be an ECU which is causing you your issue, which is then you do the half split technique. So split the medium speed CAN bus in half. Can you then talk to the rest of the vehicle? Okay, if not, disconnect the high speed. Can you talk to everything else? Okay. So I hope that answers your question, Adam. Louise, transfer case control module on Disco 3, Disco 4. Is it a gateway module? Disco 3, no, transfer case module isn't a gateway module. And Disco 4, I don't believe it is. I can quickly look while I get onto topics now. It won't take me 2 seconds. I've never known the transfer case control module on a Disco 4 to be a gateway, and it won't take me too long. So Disco 4, let's say it's a 14 model, browse all, documents, electrical information, diagrams. If I go to my high-speed CAN, no, Louise, no. The transfer case control module on the Disco 4 is not a gateway module as well. Okay, I think what you are getting is Disco 4, the transfer case control module, all right, has, if I look at it, go back to my diagram again, transfer case control module, it's got 4 wires to it, okay, and you've actually put in a very good point there. The 4 wires for the CAN, they're both high-speed CAN wires. So what it is that the CAN bus goes in and back out of the transfer case ECU. So when we talk about network topology, okay, and the structure of the CAN, what you will sometimes see, guys, is that you will have an ECU coming off the main CAN bus harness with just 2 wires. Sometimes what you will see is an ECU coming off the CAN, but it'll have 4 wires to it, but it's on the same CAN network. And as Louise has just put on there, those, when it's got 4 wires going to it on the same CAN bus network, it means that it's spurred. It's daisy chained. Okay, if it's just 2 wires, it's spurred. Now, you've made a good point. Those ECUs, because it's daisy chained rather than spurred into the network, if that goes down, it can have a similar effect of an open circuit. So the whole CAN network that it is on can knock it out. So what you have to do, and luckily Land Rover no longer do this, but they used to do it on the early Disco 4s, early Disco 3s, is that they used to spur, in this instance, the transfer case, daisy chain the transfer case ECUs into the CAN. So for testing those, what you have to do is you have to disconnect the transfer case ECU and bridge out the wires that's going in and out to complete the circuit, all right? Otherwise, whatever testing you're going to be doing is going to be false because you've essentially induced an open circuit on the CAN network, okay? If it's open, yeah, it does give you some strange problems, yes, definitely, because you will cause an open circuit on the high-speed CAN, which again, because it's an open circuit, there is a possibility that it will knock out the gateway module. So yeah, be careful, guys. Some of the early CANbus wiring diagrams, you will see on the high-speed and medium speed, some ECUs are daisy chained and some are spurred. So when you want to do your half split technique, or you want to start disconnecting ECUs, if you see there's 4 wires going to the ECU, it means it's daisy chained. So if you want to disconnect it and then bridge the wires out on the harness side to complete the circuit. Otherwise, yeah, you will get some very strange readings, and you'll get a false reading. Another question, Andrew, when you do the split test, battery off. Well, if it's doing resistance checks, Andrew, you want to do your battery disconnected, okay, because you're doing resistors, and so the way you do resistance checks, you do it with the essentially the component disconnected, so yeah, battery off. But when you're doing your voltage tests, you've got to remember to connect the battery back up. So I hope that answered your question. Any other questions, guys? I'll give it a few more minutes for anyone to type it up. But yeah, I really hope you guys enjoyed this. I hope you all at least learned something. Yeah, and hopefully I'll speak to you guys soon. All right. I think we're going to call it an end to it there. Okay. I will speak to Nicola in marketing to see about getting this PDF for those who wanted it. What's this new? All right. Cheers, guys. Stay safe and speak to you all soon. Bye.